Gregor Arturo here with the Prometheus Initiative, and now we're going to actually talk about how to replicate the geometry of our reality. So the most basic example I have right here is a triangle. Right? This is 3 neodymium magnets with 3 steel spheres, or BBs. Now, if you can see really close, I got some blue marker on it to know the south pole. South pole is the direction of the flow. And as I sort of described before, we got the flow going in a clockwise rotation. Oh, there we go. Clockwise rotation for you guys. And so you have one magnet going that way, one magnet going this way, and one magnet going that way. And so you create a flow. Now, as I was sort of talking about before, how we really want to amplify this system, we have this drawing here that I had before. Okay. Now, each sphere is going to create the rotation as shown in the image. And you got this little sphere in the center which expands outwards. Now, to duplicate that, how we're going to do that is this is where we use diamagnetism. I got a little piece of Tibetan quartz. If you stick the quartz on the inside of it, ooh, you can start to feel the frequency. It will amplify this entire system. And you also have a quartz crystal, which is programmable with a thought. And in itself, it's going to charge as a crystal. It's the most basic way to charge a crystal and to amplify it. Now, I have a piece of magnetic film here. Alright? Not sure how well you guys are going to be able to see this, so bear with me. But a magnetic film, and you can draw on it. So I can say, like, you can see that? See if I can. Yeah, can't really see it that well. But this magnet is drawing on this film. Okay? Now, if I take my little triangle, okay, and we stick it behind this guy. I'm not sure really how well you guys can see this. Alright, you can see the light. I'm not sure how much of the magnetic field you can see. Well, it's barely noticeable on this because the magnetic field is contained within the triangle. Some of you may have already been aware of this. It's most commonly done with a horseshoe magnet. And you usually take a steel bar and you stick it on the end, and you stick it up to your monitor, and you can barely, it doesn't mess up the screen as usually a magnet does, as most people are aware. But there's still some magnetic flux going out. Same with this. This has a little bit of magnetic flux going out. Well, a little bit more interesting of a model. And we have an octahedron. Okay? The one that had 6 spheres, 12 edges, and 8 faces. Now, this is basically taking this little triangle and replicating all around. So, if we got this sphere here, the energy is going this way, which is clockwise for you guys. And the 3 neighbors to it, this face, and this face, will be rotating counterclockwise. So there's 4 faces in total rowing clockwise and 4 rowing counterclockwise in this little map, in this little piece of platonic solid geometry. Now, what's most interesting, and I doubt you'll be able to really see it, on this magnetic film, there is no magnetic flux escaping from the shape, and that's perfectly flowing within inside this object. Da 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 da. Anyways, this is the basic concept of replicating pieces of geometry. However, this is just my first go at it. What really you want is the spheres to be resting actually on each other. And so, to replicate this guy, you'd want 6 spheres, the same size, but you'd actually push them all together. So, I was actually going to make a model with golf balls. So you can imagine like 6 golf balls like super glued together. Alright? Now, the magnets, what you want donuts. And the donuts would be placed in between. So here's my orange again. So it'd go like this, and the other one would go on the other side. And it would be a nice little couple to hold together. Coupler. And that's that concept. Do I need to elaborate any more on that? No. But that's the basic concept of replicating geometry with magnets and materials. However, it's going to get a little bit more complicated from here. Thanks.